Every single day in the United States, more than 50 million packages move through a vast, invisible network of warehouses, sorting hubs, and distribution centers. Behind every online order, every store shelf, and every delivery truck is a system so massive and so precise that it operates like a living organism. But here's the part most people never see. Inside these supergiant warehouses, millions of products are scanned, sorted, picked, packed, and shipped every hour, often with the help of robots moving faster than humans can think. Today, we're stepping inside the supergiant warehouse, where America sorts and moves millions of packages every day in one of the most advanced logistics systems on Earth. The journey begins long before a package is delivered. It starts at massive fulfillment centers, some of the largest buildings ever constructed. Many of these facilities cover over 1 million square feet, with ceilings reaching heights of 20 to 30 meters, allowing storage systems to stack products vertically in towering rows. Across the United States, there are over 20 billion square feet of warehouse space, forming a nationwide network that supports everything from e-commerce to manufacturing and retail distribution. Every day, thousands of trucks arrive at these facilities. At loading docks, trailers line up in long rows, each carrying tens of thousands of items. A single large warehouse can receive hundreds of trucks per day, unloading millions of individual products. The unloading process is fast and coordinated. Workers and machines remove pallets using forklifts, while conveyor belts carry boxes directly into the system. Some facilities process up to 10,000 packages per hour just at the intake stage. As soon as products enter the building, they are scanned. Barcodes and RFID tags are read instantly, feeding data into centralized systems that track every item in real time. From that moment on, every movement of every package is recorded and optimized. Next comes storage, and this is where the scale becomes truly impressive. Inside these warehouses, shelves stretch for kilometers. In automated facilities, robotic systems move entire racks of products instead of workers walking through aisles. These robots can travel at speeds of up to 2 meters per second, carrying hundreds of kilograms at a time. Some warehouses store millions of individual items, from small electronics to large appliances. Advanced algorithms determine exactly where each item should be placed to minimize retrieval time later. This level of optimization allows the system to function with incredible efficiency. Then comes one of the most critical steps: picking. When a customer places an order, the system immediately identifies the location of each item. Instructions are sent to workers or robots, guiding them through the fastest possible route. In highly automated centers, robots bring entire shelves directly to human operators. In others, workers use handheld devices or wearable technology that directs them step by step. A single worker can pick 100 to 300 items per hour, while robotic systems can assist in moving thousands of items across the floor simultaneously. Once items are picked, they move to packing stations. Here, products are scanned again, checked for accuracy, and placed into boxes. Automated machines can measure item dimensions and select the most efficient packaging size, reducing waste and shipping costs. High-speed packing lines can process thousands of orders per hour, sealing boxes, applying labels, and preparing them for shipment. From packing, packages move on to conveyor systems, and this is where the operation reaches another level. Conveyor belts stretch across entire buildings, sometimes totaling several kilometers in length. Packages travel at speeds of up to 3 meters per second, moving through scanning tunnels and sorting systems. Advanced sorting machines can process 20,000 to 50,000 packages per hour, directing each box to the correct destination based on its delivery address. At major sorting hubs, the scale is even larger. Facilities operated by logistics companies handle hundreds of thousands of packages per day. Automated arms, tilt tray sorters, and cross-belt systems ensure that each package is routed correctly within seconds. From there, packages are loaded onto outbound trucks, airplanes, or delivery vans. A single large warehouse can ship out over 1 million packages per day, depending on demand. The logistics network that connects these facilities is just as massive. Trucks travel across highways non-stop, moving goods between warehouses and distribution centers. Cargo planes carry urgent shipments across the country overnight. Local delivery fleets handle the final step, bringing packages directly to homes and businesses. Timing is everything. Many systems are designed so that an order placed in the morning can be picked, packed, sorted, and shipped within just a few hours. This speed is made possible by advanced technology. Artificial intelligence predicts demand, ensuring that popular products are stored closer to customers. Machine learning algorithms optimize routes inside warehouses. Sensors monitor equipment performance, preventing downtime. Some facilities even use computer vision systems to detect damaged packages or errors automatically. The result is a system that operates with incredible precision. But behind all this technology, human workers remain essential. They manage operations, solve unexpected problems, and ensure that everything runs smoothly. In peak seasons, such as holidays, warehouses can employ thousands of workers, all working together to handle surges in demand. Safety is also a major focus. With heavy equipment, fast-moving conveyors, and constant activity, warehouses are designed with strict safety protocols. Training, protective gear, and monitoring systems help reduce risks and protect workers. What makes this industry truly remarkable is its scale and coordination. Millions of items move through these systems every day, yet most deliveries arrive on time, often within 1 or 2 days. From the outside, it may seem simple. Click a button, receive a package. But inside the supergiant warehouse, a complex and powerful system is at work. A system that connects manufacturers, retailers, transportation networks, and customers into a single, seamless flow. A system that transforms raw logistics into speed, efficiency, and reliability. And a system that continues to evolve. New technologies like autonomous robots, drone delivery, and fully automated warehouses are already being tested and deployed. These innovations could make the process even faster and more efficient in the years ahead. From massive buildings filled with millions of products to high-speed sorting systems that never stop moving, the supergiant warehouse is one of the most important and most overlooked parts of the modern economy, because without it, nothing moves. No packages, no products, no supply chains, just empty shelves. If you enjoyed this journey inside one of the most advanced systems on Earth, make sure to like, subscribe, and hit the notification bell so you never miss our next deep dive into the industries that power our world. Thanks for watching. take shape. The journey starts when trucks loaded with old and broken panels arrive at the facility. Some are cracked from hailstorms, some are yellowed from decades of exposure, others are simply outdated and replaced by newer, more efficient models. Workers and robotic arms unload the panels and send them onto conveyor belts. Each panel may look like trash, but inside are materials that are far too valuable to throw away: aluminum, silver, copper, high-purity silicon. The first step is shredding. At this stage, the solar panels are fed into enormous machines with rotating steel jaws. In seconds, what was once a gleaming panel is reduced to fragments. Glass, plastic, and silicon shatter into small pieces while metals are torn free. To an outsider, it looks like destruction, but in reality, it is the first step toward rebirth. Breaking the panel down is the only way to separate its components. After shredding, the fragments move onto the sorting line. This is where chaos is transformed into order. The first separation is magnetic. Large magnets attract steel parts, screws, nails, mounting hardware, pulling them away from the stream. What remains continues forward, where powerful eddy current separators push aluminum aside. Aluminum frames, once holding the panels together, are now collected to be melted down and reused in new construction, or even new solar panels. The next step focuses on the glass. Solar panels are about 70 to 80% glass by weight. Shredded glass particles are filtered and cleaned until they can be reused. Some of this glass ends up in new solar panels, while others are recycled into bottles, insulation, or building materials. Nothing is wasted, but the most important part is still hidden within the mix: the silicon cells. These delicate blue wafers are the true engines of the panel, and recovering them is both the most difficult and the most valuable task. To reach them, specialized processes are used. One technique involves heating the shredded material to soften and peel away the thin plastic encapsulant layers that cling tightly to the silicon. Once freed, the wafers can be purified, melted, and transformed into new cells for new panels. This recovery of silicon is groundbreaking. Silicon is one of the most abundant elements on Earth, but producing it in the ultra-pure form needed for solar cells is energy-intensive and costly. Recycling old cells into new ones saves enormous amounts of energy and resources. In some advanced plants, over 90% of the silicon is successfully recovered. Then comes the silver. Each solar panel contains thin lines of silver paste that collect electrons from the silicon. Silver is rare and expensive, making up nearly half of the panel's total material value. Through chemical baths and electrolytic processes, the silver is stripped out, purified, and collected. These recovered grams of silver, multiplied by millions of panels, create a supply worth billions of dollars. Step by step, the supergiant recycling plant transforms waste into treasure. Broken panels become glass cullets, aluminum ingots, silicon wafers, silver bars. From destruction comes creation, and from trash comes power once again. The scale of the operation is breathtaking. Conveyor belts stretch for hundreds of meters. Robotic arms sort materials with speed and precision. Entire mountains of waste shrink as truckloads of clean raw materials roll out the other side. What once looked like a problem, the end of a solar panel's life, has become an opportunity. But the story is not just about machines. It is about the future of energy itself. Solar power has grown faster than anyone predicted. In the United States alone, enough solar energy is installed every year to power millions of homes. Globally, we are adding hundreds of gigawatts annually. And with every installation comes the responsibility of dealing with the panels when their time is up. If we do not recycle them, they could end up in landfills, leaking toxic substances, and wasting valuable resources. But if we do recycle them, we close the loop, creating a sustainable cycle where old panels give birth to new ones, where today's waste becomes tomorrow's clean energy. This is why solar panel recycling is more than an industrial process. It is a vision of the future. Imagine a world where every solar panel is reborn, where no resource is wasted, where the sunlight of yesterday fuels the sunlight of tomorrow. At the heart of this vision are the silicon cells, tiny, fragile, but infinitely powerful. They remind us that technology is not just about invention, it is about reinvention, the ability to give life again and again. If you believe in a future where technology and nature work hand in hand, then join us on this journey. So hit that subscribe button, and let's keep building a brighter, cleaner tomorrow, one story at a time. Paper is everywhere. From the cardboard boxes that arrive on your doorstep to the napkin you use at lunch, from the notebook you jot down ideas in to the packaging that protects your groceries. Paper is one of the most versatile and widely used materials on Earth. But with this massive use comes an equally massive problem: waste. Every year, humanity produces more than 400 million tons of paper and cardboard, and almost half of it is thrown away after just one use. Without recycling, we would be drowning in mountains of paper waste. And that's where the story of supergiant paper recycling plants begins. These are colossal facilities, some the size of entire sports stadiums, where mountains of discarded paper are transformed into brand new packaging materials. The process is nothing short of mind-blowing, taking yesterday's trash and turning it into tomorrow's box, tomorrow's shopping bag, or tomorrow's food container. To appreciate the genius of paper recycling, we need to understand the scale of the problem. The world throws away more than 200 million tons of paper waste every year. In the United States alone, around 67 million tons of paper and cardboard are used annually. Enough to fill more than 1,000 Empire State Buildings from top to bottom. But here's the good news. Paper is one of the most successfully recycled materials in human history. Nearly 70% of paper waste in the US is recycled, a rate higher than plastics, glass, or even metals like aluminum. In Europe, the rate is even higher, sometimes reaching 80%. This means the majority of the packaging you touch every day has already lived a previous life, perhaps as a school notebook, a cereal box, or even yesterday's newspaper.